Hello friends, welcome to this lecture on computer-aided power system analysis. We have been discussing the formulation of Y-bus matrix for a three-phase unbalanced system. We have first looked into the case where there is no transformer, but now we are in the process of looking into the case where there is one transformer in a network. So far we have been looked into the case that we have actually taken into consideration a very small system which is shown here, which is basically a 5-bus system 1, 2, 3, 4, 5, and there are basically 4 lines between the buses 1, 2, 3, 4, 1, 5 and 4, 5, and we have also one transformer, 3-phase transformer between bus 2 and 3. And we have also earlier shown that any 3-phase unbalanced transformer having any kind of transformer connection can be modeled by this kind of equation: I1 ABC, I2 ABC is equal to this Y1, Y2, Y3, Y4 into Vm ABC and Vn ABC. We have also indicated that what are those currents I1, I2 as well as what are those buses Vm and Vn. So, now today we would be actually continuing from this, and we have also written the equation corresponding to bus 1 as shown here, and now we would be essentially writing the equations for bus 2, bus 3, bus 4 and bus 5, and after that we would be writing these equations, writing those equations in a matrix form to ultimately form the Y-bus matrix. Now, for the purpose of writing the equations in at bus 2 and bus 3, let us denote that this bus 2 is denoted as bus M. So, let us say that bus 2 is bus M, and let us say that bus 3 is bus bus N, and let us say that this is I1 ABC, let us say that this is I1 ABC, and let us say this current is I2 ABC. So, then therefore, as far as this transformer model is concerned, it will be looking like this, that so then transformer model would be, the transformer model would be actually we should not write here I2 ABC, because here we are simply writing, because earlier we have already denoted I2 ABC as the injected current in bus 2 and I1 ABC as the injected current at bus 1. So, let us say that we denote this is primary ABC and let us say this is secondary ABC. So, let us say that this is IP ABC and let us say IS ABC, IP ABC and IS ABC, and this is bus M and this is bus N. So, then therefore, according to this and according to whatever you have already discussed, the transformer model would be IP ABC and IS ABC is equal to Y1, Y2, Y3, Y4, V2 ABC, V3 ABC. So, then therefore, IP ABC can be written as Y1 V2 ABC plus Y2 V3 ABC, and IS ABC can be written as Y3 V2 ABC plus Y4 V3 ABC. Please note that all these currents and voltages are all complex quantities. So, now with this now we are ready to write down the equations at bus 2. So, at bus 2 the equations would be now I 2 ABC would be nothing but IP ABC plus I 21 ABC. So, let us say this current is I 21 ABC. So, this current is I 21 ABC. So, then therefore, at bus 2 I 2 ABC is equal to, at bus 2 I 2 ABC is equal to IP ABC plus I 21 ABC. IP ABC is, we write from here Y 2 V 2 sorry Y 1 V 2 ABC plus Y 2 V 3 ABC, and I 21 ABC would be essentially it would be Y 1 2 ABC into V 2 ABC minus V 1 ABC. We have already defined what is meant by Y 1 2 ABC. So, then therefore, I 2 ABC would be given by, now we write minus Y 1 2 ABC V 1 ABC plus, we take V 2 ABC together. So, it is Y 1 plus Y 1 2 ABC into V 2 ABC plus Y 2 into V 3 ABC. So, this is equation 2. Okay, we carry on. So, now we write the equations at bus 3. At bus 3, what are the equations? Now, at bus 3, if I 3 ABC is the injected current, so that current would be this current plus, let us say this is I 34 ABC. So, this would be I 34 ABC. So, I 3 ABC would be equal to IS ABC plus I 34 ABC. So, I 3 ABC would be is equal to IS ABC plus I 34 ABC. IS ABC is given by Y 3 V 2 ABC plus Y 4 V 3 ABC. So, Y 3 V 2 ABC plus Y 4 V 3 ABC, and I 34 ABC would be Y 34 ABC into V 3 ABC minus V 4 ABC. So, it would be Y 3 V 2 ABC plus, we collect the terms of V 3 ABC together. So, it is Y 4 plus Y 34 ABC into V 3 ABC minus Y 34 ABC into V 4 ABC. So, this is equation 3. Well, so these are the only, so these are the equations at bus 2 and 3 we needed to write down explicitly, and bus 4 and 5, this equation should be very simple. At bus 4 and 5, what would be the equation? It will be minus y34 ABC. At bus 4, I4 ABC would be minus y34 ABC into V3 ABC plus, let's say, y44 ABC into V4 ABC, and then minus y, let's say 4 5 ABC, 4 5 ABC into V5 ABC. So this is the fourth, and where y44 ABC is nothing but y44 ABC would be sorry, actually there is something missing here. Basically this currents also will have, please note that this current also will have some shunt component which we have neglected here. So then so here plus it should be y12 shunt ABC into V2 ABC. So then therefore y12 shunt ABC plus V2 ABC, this term would be added here. So here also there is another term will come, and this term would be y12 shunt ABC. So this term would be y12 shunt ABC and plus this. So that would be the case. Similarly here also plus it should be y34 shunt ABC into V3 ABC. So then here also we will have y34 shunt into ABC here. So it would be, so it would be this, so it would be this. So y44 ABC would be nothing but y34 ABC plus y34 shunt ABC plus y45 ABC shunt plus y45 ABC. And bus 5 again, so this is equation 4. So it is I5 ABC is equal to, I5 ABC is equal to nothing but minus y minus y15 V1 ABC minus y15 ABC to V1 ABC minus y45 ABC into V4 ABC plus y55 ABC into V5 ABC. This is equation 5, and this V5 ABC, sorry, y55 y55 is equal to y15 ABC plus y15 shunt ABC plus y45 ABC plus y4 5 shunt ABC. So these are the 5 equations. So now after writing all these 5 equations, we are now ready to write down the in matrix form. So we write in matrix form so what I have got I1 ABC, I2 ABC, I3 ABC, V1 ABC, V2 ABC, so this, and again we do the partition. So now when we do this partition, after that it will be very easy to write. So then this partition should be, so I1 is minus, sorry, y11 v1 ABC. So this is y11 ABC minus 1 2 ABC, and then minus 1 5 v5 ABC minus 1 5 ABC. These are all 0. Please note that all these are actually 3 cross 3. Everything is 3 cross 3 here. All these matrices. Then bus 2 minus 1 2 v1 ABC. Bus 2 is minus 1 2 ABC, and then y3 v3 ABC. This is y3, so it is 1 2 3. This is y3. Then all are 0. It is not there in this equation. This is not there. So this is y1 plus y1 to ABC plus y1 to shunt ABC. So this is y1 plus y1 to ABC plus y1 to shunt ABC. So this is what it is. Bus 3 y3 v2 ABC, y3 v2 ABC. It is y3. This is actually y2. This is y2, y3 v3 ABC, and then minus y3 4 ABC v4. So minus y3 4 ABC v4. This is 0. This is also 0. And this one is y4 plus y3 4 ABC plus y3 4 shunt ABC. So it is y4 plus y3 4 ABC plus y3 shunt ABC. Then what we have is bus 4. Bus 4 is minus y3 4 v3 minus y3 4 v3 y4 4 minus y4 5 v5 all are 0. and bus 5 is minus 1 5 V1 minus 1 5, then minus Y4 5 Y5 5 over 0. So, this is the Y bus matrix. So, we can see that it is a 15 cross 15 matrix as usual, because this is a 15 cross 1 vector as usual. This is also a 15 cross 1 vector. So, now here you can see that this matrices Y1, Y2, Y3 and Y4, they are already appearing here, but along with other elements. Although this particular admittance matrix is made by this way, but the problem is that, I mean, if suppose for example, if there are a very large system where there are a very large number of transformers, say for example, there is an let us say a 5000 bus system, and let us say there are 200 transformers, and these 200 transformers are actually connected between let us say different buses. So, then the question is that how do we evolve an automatic algorithm, computer based algorithm, so that these transformer matrices would be automatically embedded into the Y bus matrix. Right now, just by looking at this particular matrix, it is not very clear that where these elements will be appearing. Only thing is that we are being able to say that because this particular matrix, I mean, because this particular transformer is connected between bus 2 and bus 3. So, then therefore, these 4 matrices Y1, Y2, Y3 and Y4 are only appearing at the elements connected to bus 2 and bus 3, but then suppose for example, if there are let us say 200 such transformers which are connected between different 2 sets of buses. So, then therefore, how an automatic computer algorithm can be made, so that these matrices would be automatically embedded into the bus admittance matrix. So, to understand that, what we will do now, that we will now again reconsider the earlier system as shown. Only thing is that we will now simply remove this transformer. So, only thing is now we will remove this transformer. So, now what we will do is, now we will reconsider the system, we will now reconsider the system. So, now reconsider the system, reconsider the system by removing the transformer, by removing the transformer. So, then if I do reconsider the system by removing the transformer, then this system looks like this. So, I have got bus 1 and then bus 2, bus 3, bus 4 and bus 5. So, this is bus 1, this is bus 2, bus 3, this is bus 4, this is bus 5, and we have also these lines are connected. So, lines are connected between bus 1 and 2, between bus 3 and 4, between bus 4 and 5, and between bus 1 and 5. So, here essentially it is the same system we are considering. Please note that it is the same system we are considering as we have shown. Only thing is that we have simply removing the transformer. So, then therefore, there is nothing connected between these 2 buses, as if that basically there is no open circuit between these 2 buses, bus 2 and bus 3. And as usual, now what we will do, as usual, we also write I1 ABC, then I5 ABC, These are the injected currents I 4 ABC, I 3 ABC and I 2 ABC, I 2 ABC, and of course, these voltages are V 1 ABC, V 2 ABC, V 3 ABC, V 4 ABC, V 5 ABC. So, now this is the system in which this original transformer has been altogether removed. So, now what we will do is that now we will write down the Y bus matrix of this system in which there is no transformer. So, then when we write down the Y bus matrix of this system, so we write down the Y bus matrix of this system. So, now we will write down the Y bus matrix of this, say it is reduced system, So, what we will do is that we will essentially write down the Y bus matrix of this particular reduced system, and then we will compare this Y bus matrix of the reduced system with the original Y bus matrix whatever we have just now written, and then by comparing these two Y bus matrices we would be able to find out an automatic algorithm by which these 4 sub matrices corresponding to a transformer, that is Y 1, Y 2 and Y 3 and Y 4, can be automatically embedded into the overall system Y bus matrix. So, this exercise we will be doing into the next lecture. Thank you.